So next, we'll have Xieyang from CMU HCII, presenting work with co-authors from CMU as well as alum from now at AI2. And this is a very interesting technique that kind of leverages how humans are already kind of moving their cursors around to be able to collect information on the web.
Cool. All right, thank you, Anhom, for the nice introduction. Good afternoon, everyone. I'll present our paper, Wigglite, Low-Cost Information Collection and Triage. My name is Xieyang, and this is joint work with my awesome collaborators, Andrew, Yongsung, Joseph, who's here, and my PhD advisors, Aniket, Kittur, and Brad Myers. We're from the HCI Institute at Carnegie Mellon. So in this talk, I'm going to talk about capturing information, or specifically capturing information when performing sense-making activities online. So the scenarios could be consumers conducting comparison shopping, it could be patients researching their recent medical diagnoses, or it could be developers looking for code or solutions online. When people are doing these kind of tasks, they frequently try to collect some information that they think are useful or important for later use. But what if you're trying to actually learn and also make a decision afterwards? For example, to buy a new camera, which I just did, we might discover many different options from various websites while trying to prioritize which one best fits our expectations or use cases, and also looking for review articles and photo samples maybe that speak either positively or negatively about those cameras. And as you probably have guessed, just collecting information isn't quite enough here. So research showed that in these circumstances, people also want to triage the collected information, or put it in another way, keep track of their sort of mental judgments. For example, if it is a pro or a con, or what we call valence, or it could also be whether I should put this information on top of my stack to follow up on, or it should really go into my back burner, aka the priority. However, if I try to keep track of everything using, let's say, Google Doc, or any other typical note-taking app that people normally use, there is a very high cost and a lot of interruptions involved. As you can see, like copy-pasting information, collecting evidence, taking screenshots, putting them in a doc, and then typing out my thoughts about it, and going back and forth. And what if you need to do all of these on your phone, right? If you think about it, we need to sort of do a long tap and then drag the two handles to specify how much content you want to select, and then you copy the text using the pop-up, then switch to a note-taking app and put it in or paste it in, and then type your thoughts and opinions, and then after all these, you need to context switch back to where you were and try to reorient yourself. And indeed, recent survey showed that even though participants do sort of these sense-making stuff a lot using their phones, they're not happy with their current process of selecting and also saving content, let alone capturing their mental models or judgments afterwards. So to summarize, with the amount of information we have to process today and the limited tool support that we have, it is cognitively and also physically demanding for us to collect and triage information when performing sense-making tasks on mobile and desktop devices. And as a result, people usually just try to keep everything in their head, which, believe it or not, could quite become, intractable. And most of the prior work on making selections or copying content easier doesn't really address this additional need of people wanting to triage the content right after collecting it, right? So instead of having to do all of the clicking, dragging, context switching, what if we can make this process dramatically simpler and easier? So in this work, we propose an interaction technique where the user only needs to wiggle their mouse cursor over the desired content back and forth for a few times to select and save that content, as you can see on the screen, hopefully. And if they would like to encode their judgment of that content, for example, if it is pro or con, they can naturally finish the wiggle gesture by swiping left or right. I'm doing it backwards. This encoding of the valence information was actually heavily used by our participants in our evaluation. More on that later. And the nice thing here is that we can also map the amount of mouse travel to, let's say, the degree of the valence, like what is shown on the screen here. In addition, we can also sort of take advantage of the vertical dimension by ending the wiggle with a swipe upwards or back or downwards to encode, say, how urgent it should be, or how urgent should we follow up on this topic, aka the priority, like I mentioned. And again, by taking advantage of the amount of mouse travel, up or down, we can comfortably squeeze into additional levels of priorities. And similarly on the phone, we can trigger a selection and save by making these small up and down scroll movements, and after that swipe to the left and right to encode valence information. This is actually taking advantage of the fact that the content will, for the most of the time, move along with the touch point on a mobile phone, provided that there's only one touch point on the screen. So you might be wondering why wiggling? So naturally, we took an iterative design process to find an interaction that would be accurate enough to select the things that we want, and also be very efficient to perform, and is expressive enough to be able to encode our mental judgments, and last but not least, can be nicely integrated into all the gestures and interactions that we already perform and do not interfere with them, right? So after lots of initial prototypes, such as drawing different shapes to mean different encodings, we found that the current wiggling gesture strikes a nice balance between a lot of these properties. So for example, prior work has shown that when doing the active reading or learning tasks, people often unconsciously have their mouse cursor follow their gaze. So the cursor may already be available to wiggle on the content that they are interested in, as opposed to move it all the way across the screen. And also, compared to the conventional way of selecting text by clicking and carefully dragging the mouse cursor, wiggling doesn't need you to click your mouse buttons, which, believe it or not, itself is a cognitive decision, or you don't have to be super precise in terms of your mouse cursor movements, which requires some fine motor skills. And also, perhaps most importantly, we can naturally end the wiggle with a swipe to different directions to encode additional properties of the information that we are collecting. So, and our informal testing has shown that the time and effort to actually to perform that additional swipe is negligible. And the wiggling the cursor on desktop hasn't really been tapped by any of the existing applications, and the up and down scrolling movements hasn't been overloaded by any of the mobile operating systems. And last but not least, the back and forth or the up and down pattern is also pretty unique. It is practically robust against false positives, meaning that in general it is pretty hard to mistrigger a wiggle when moving your mouse around in your day-to-day use. So to make the wiggling technique more concrete and also more usable and testable, we've built a sense-making system that encapsulates the wiggling technique. That allows you to save and triage clips of information into a holding tank, and supports filtering, sorting, and archiving, and you can later move them into the topics view for further organization. And we call this prototype Wigglite. So here's the fun part, which stands for Wiggling for Information Gathering and Generating Lightweight Impressions for Triage and Encoding. When I first started my PhD, I would never imagine that I can write a paper with the word wiggle in the title, but here we are. And no, it is not an acronym for a real rock or gemstone. This image was actually generated by DALL-E using the prompt, a piece of rock that is called Wigglite, which shows lots of wiggles on the surface. I sincerely hope my advisor Brad is okay with this. So that was a high-level walkthrough of how Wigglite works. For evaluation, we conducted a lab study to understand how well it can help people collect information as well as encode aspects of their mental context when doing sense-making tasks, compared to a baseline system which offers text and screenshot clipping features that people commonly have access to, and users can manually attach notes to the clippings to express their mental judgments. And note that the study was done using the desktop version, and we leave the proper evaluation of the mobile version for future work. So in the end, we found that using Wigglite incurs significantly less overhead cost, which means that people were better able to actually focus on reading and comprehending the actual web content that they should be focusing on. And also, in addition, it also helped participants speed up their sense-making processes. So these evidence speaks to the efficiency design goal. So what about the other design goals? If we look at the expressiveness, participants collected almost twice as many clips using Wiggling compared to the baseline, and almost 80% of them were either encoded with a valence or a priority, which suggests that people indeed were able to use Wigglite to naturally express their judgments towards information that they just collected. And last but not least, if we look at the false negatives, 3.5% of the wiggles were misrecognized. It's either due to the wiggle did not activate or it collected something that the participant did not want. But there was no false positives, meaning that normal mouse movements and actions would not trigger a wiggle. And these are fairly robust numbers, I would say, and suggest that at least with the current prototype implementation and with some training beforehand, which the participant received before the study, wiggling is accurate and also do not interfere with existing interactions and user behaviors. And future work can improve the recognition algorithm to further lower the false negative rate and potentially investigate if and how people's wiggling performance changes over time. And participants also thought Wiggling provided them with a fluid workflow when sense making. So for example, I just wiggled and move on. In fact, when I'm wiggling on something, my eyes are already on to the next paragraph. No more stopping to do the regular clipping thing anymore. And also, participants wondered if they could customize the system, such as by writing some sort of plugin to map the different directional swipes to what I want, depending on the situations I'm in. Which, as I mentioned, could very well be a future direction that we can explore. So, to conclude, there's a high cost involved for people to efficiently collect information they find for later use, and at the same time externalize their mental judgment about that information. In this case, the valence and priority, while doing online sense-making and exploration tasks. And to address that, we explored the design space of some lightweight interactions and introduced a technique called wiggling that enables the collecting and triaging of information in a single gesture that works on both desktop and mobile devices. We also envision that this technique can, in the future, maybe be customized by users and extended to support a wide range of custom actions, possibly beyond sense making. That is all I have. Please feel free to ask any questions, and I hope you enjoy Andrew's talk later in this session. Thank you.
Any questions?
Konrad Lempert, HPI. I like the technique. I'm taking a ton of screenshots usually, so this would be nice to have. I'm wondering if you thought about how to make it discoverable, like how should people learn about this technique? Is there an intuitive way?
Mm-hmm. Yeah, that is actually a great question. We thought about this a lot. In the end, we kind of try to strike a balance between it being not super obnoxious or because right now the wiggling, notice that you don't have to sort of click any mouse button. You just start to wiggle and it will automatically be recognized. We don't want it to be the way that the other sort of collection mode does it, which need to click some button and then enter that mode, and you need to remember to exit that. So yeah, the discoverability is actually something we need to work on. But yeah, I think that's a good question.
Thank you.
Yep. Thanks. You want to set up or?
Please set up.
Yep.
Hi, I'm Cassidy Trier from the Allen Institute for AI.